13 is supposed to be C. I put A in there.
All right. All right, so like I can see why you would put C, because I probably would too. Because it says 2 moles of H2 and you got 2 moles of H2, 1 mole of O2, and you're like, okay, that's what I want. They're in the but they're saying here that H2 is, you're sure the answer is A?
Yeah, 13 is, oh wait, no, 13 is C. Never mind,
13
I
is
put
C.
A.
Okay, because 13 is the same reason as 11. You use the mole coefficients, so if you look at any balanced equation, whatever the mole coefficients are, or the coefficients of the balanced equation, that mole ratio is what is fully consumed.
Mhm. So this one, so H is +4 and O is +2 on the top.
Yeah, but no. O would be 0, and these are both 0. But
Oh.
you're so okay. So I feel like you're mixing some things up here. I'm just gonna say some obvious things. H2 means 2 H's. The 2 in front is the balanced number, and that's the mole. That's when they say 2 moles, they're referring to this 2 right here. 1 mole is the 1 in front.
Okay.
And just like in the previous problem here, like the 1 and the 4 are the numbers in front. That's what's fully consumed when there's no excess.
Hold on, I'm just putting this down. Okay, so 2 moles of H2 react with 1 mole. So 1 and 2. It just balances out. So it's
Right. So we're talking about different things, that like there's the balanced equation, which is great, but then to determine what's limiting, if they give you the same number of moles of each, then it's fully consumed. Like you can't mix grams and moles, is what I'm trying to
Mhm.
say over and over again.
So with grams, I'm looking for the coefficient.
No, like you never want to use grams. Like only time you use grams is when it asks for grams, because you always convert grams to moles.
Oh, okay. So you just look for like the charges and stuff and see if they
No, this is nothing to do with that. Nothing to do with that. Let me just find another balanced equation to just sort of like use as an example. So let's just say CH4 plus 4Cl2 produces CCl4 plus 4HCl. Okay. Do you see how the CH4, it has 1 mole, and the Cl2 has it's 4 moles?
4 mole. Okay.
So in the reactant side, if
Oh yeah, you're okay. So 1 mole, 4 mole, and on the right it's 1 mole of carbon and 1 mole of Cl4.
well, it's CCl4, whatever that is. It might be
CCl4.
like tetrachloride or something, but
Okay.
this is
And it's
4
4
hydrochloride.
mole of HCl.
Yes.
Oh, okay. So you're
Yes.
just looking to see if they line up or if they don't. And
Right.
in this case, they line up all the way.
Yeah, like if it said 1 mole of H2 is reacted with 1 mole of O2, then we'd have an issue, because then we'd have to actually do something. But because they give you the coefficients, you don't have to do anything to do it. It's like an obvious question if you understand the ratios, but I can see where you would maybe go sideways, because if you're confused about this grams or charges, it has nothing to do with grams or
So
charges.
on the right, is it 2 moles of H2 and 2 moles of O2?
No,
Or is it 1 mole of O2?
It's 2 moles of H2O,
Okay.
2 moles of water.
Fully consumed. No limiting reactant. Okay. What is next? Number 14.
just more, I guess, common here is like when you drink water, you don't like H2O is water. Like I don't think I'm drinking H's and then O's. Like it's water. It's a compound. So maybe that's it's the moles of a compound. So you said 14. 14 is the next one, Jack.
Yeah, the answer is C. I put D in
Okay,
there.
so single replacement. That means only one. Like here are the single replacements. Like A, B plus C goes to AC plus B.
Mhm.
That's kind of what you're looking for. Or sometimes it's A plus BC produces, AC plus B basically. So one, like you're looking for the one that's got, so A is out. A is out because it's a single element there. Okay. And D is out because there's two and two. Like it's AgNO3 and NaCl. There's two things there. B is out because you're not adding two things. So it must be C. Again, do you like, let's just look here. Do you see how the like the Fe in this case is like the A? And the Cl is like the B. Okay. And then the zinc is like the C here. So you can see that like one's going to mix, like and we don't know which one. I just chose C, but in this case, the zinc's going with the Cl,
Yeah.
right? And just to be clear, like this is decomposition. You sent me a picture. The last one's double replacement. The first one where they combine together is called synthesis. Should know
Mhm.
that. I say that all the time. And this is the single replacement. I guess the one you're missing is combustion, where it adds water. But anyway, you have to know each of these, by type. Like A plus B forms AB together. AB forms A individually and B individually. And then, single replacement is where one of these form with this one, leaving the other one off to its lonesome self.
Yeah, this one's just me getting sloppy, basically.
Yeah. 15, like if you didn't get the answer to 15, you should be able to answer it now, sort of.
No, I got 15. 15
Okay.
was right. All
Okay.
right, I think that 17 and 18 are the ones that I got wrong.
Okay. So 17,
I thought this one was double replacement, but apparently not.
so it has the look of that, but because you've got two on the left and two on the right. Okay. That's why you might go double. But one of the things here, when water is formed, that's a big deal. Water is formed. Does that mean anything to you?
Uh, that one means that. Is there a combination in there?
So no, like, but that's like that should draw you in. The fact that water is formed. Okay, so a combustion reaction always has water in it. So that's the key to noticing it.
Oh. So original answer I put C, double replacement.
So they say it this way: fuel plus O2 yields CO2 plus H2O in a combustion reaction.
Fuel plus O2, CO2 plus H2O, combustion reaction.
Right. So they often cite like a lighting of a match, which I don't really know where the water comes in, but that is what it is. What it is.
It's supposed to be. So it's combustion because of the water.
Yes. Yes. So like in addition to the four that we did in the previous problem, the last one is combustion that they ask you to know.
Okay, 18, I did not know.
18.
This one made no sense. This one's a definition problem that I didn't really know.
Yeah, I guess we'd want to look at a double reaction to know whether they do or don't. Do any of the atoms change their charge? So I would have no way to know this without looking in the textbook, because it's let me think of let me look at a classic double example, double replacement example here. Okay. I don't know why the internet can't just give me one. That's okay. Here we go. So BaCl2 plus MgSO4 produces BaSO4. Notice that the Ba went with the SO4 plus the Mg and the Cl2. Okay. So this is our double reaction here. The question is like, did they change charge? And I guess I would say that they don't, but
Yeah, this one makes no sense to me.
change charge. So it says no. It says no. So the idea here is that if Ba is +2, it's also going to be +2 over here. And so does that work? So what is SO4? What is the charge on SO4? Well, we know that Mg is +2, so SO4 is going to be -2. And so this matches up on this side. And then Cl is -1, but you have two of them. So that's why when you have the Mg over here, +2, it's -1. So they do not, looks like they do not change their charges in a double replacement.
So how can I say why I would know that? So
Yeah, why? Because it's why the good question. Because you want to say that the net charges have to remain. Net charges of the new compounds or the products must be neutral.
so net charges of the what?
Of the new compounds, the reactants, the net charges of the reactants need to be also neutral.
Okay. What about, all right, next is number 19.
Okay.
19, the correct answer is D. I put A on there.
Iron-3 chloride reacts with sodium hydroxide. Predict the products when iron-3 chloride reacts with sodium hydroxide, double replacement. Okay. So that means the Fe is going to go with the OH. That's the first part of the replacement. So that eliminates a few of these. We don't know the charge yet, but that eliminates a couple of these. Plus the NaCl for the other one. Okay, so NaCl3 is completely wrong. I know that from just it's always Na and then Cl, because Na is +1, Cl is -1. So we're down to these. So the 3 here in the Roman numerals, that means it's got a charge of +3. So since from the previous one, since we know that Fe has to keep its charge, the only way to do this with the OH is to make it 3, because the OH is -1. OH has a charge of -1. So that's why I have to put the 3 on the outside, because it's 2 of them or 3 of them. The Fe with the 3 underscript would mean 3 Fe's, and that would change its charge to +9. That's totally unreasonable.
So how do you know that iron is +3 in this case? Oh wait,
Right here,
because of the
right
3
there.
right there.
Yep.
Oh, that's why.
Yep.
Okay.
Whatever's in the Roman numeral, you'll see it with a 2 or 4 occasionally.
And you know that. What would you do with OH though?
OH is known to be -1. It's
Oh,
just,
OH.
it's
OH
like a,
so -1.
yes.
One charge. Oh, okay, so then the Fe and the OH cancel out. So then that just goes to D.
Yeah, so it has to be D. Like basically we were getting it down to 2 choices and
D is the only right one. Okay. That makes more sense. What about number 21, 21, 22, and 23? And after that's 28, and then we're done.
21, predict the products.
21's answer is B. I put A.
All right, so we got strontium oxide. Products. Oh, products. Okay, strontium oxide. So SrO something maybe plus magnesium produces. So we need to know the charge of strontium, and that's a +2. So the O is a -2 plus magnesium. So this is going to be well, I don't know what the seems. I'm leaning towards single replacement, like MgO plus Sr. What did you say the answer is? B?
21 is, yeah, it is B.
Okay. Now magnesium also has a charge of +2, so that's why it just nicely pairs with the O and the single replacement. I think this is the hardest thing to do is to do the reactions, get them right.
Predict products. All right, so SR plus Mg. So the metal always goes with the non-metal, so MgO. And
Oh
then
yeah, that's another way
Oh.
to do it. Yeah, that's another way to do it.
okay. Non-metal goes with metal. Single replacement. So it's just B.
Yes.
Okay.
Did you say
And
you said 22?
22 and 23. So 22, the right answer is B. I put A.
So we need to look at what makes a redox reaction. Transfer of electrons. Transfer of electrons. NaOH. So like the fact that water is formed leads me to believe that this is a combustion reaction
I'll pull up my
or something else. I guess that's where I'm would answer it or correct it.
So 20.
Sorry, or synthesis. I guess synthesis would be also possible. But I believe because it's not synthesis because it's only it doesn't just form water. So
Where's false? So I forget. So redox reaction is where the
there's an
So,
exchange of electrons.
electrons, yeah. So how can I put the charges up correctly?
But this is not, this is false. You said this is false, and this is, so that we're saying that's why it's not. There is no exchange of electrons and water is formed, so it's something else.
No exchange of electrons. And there's water in it.
Yes. I think that might be a reasonable way of saying it.
All right, number 23. The actual real answer for that is A. I put B.
It's a redox reaction.
So it is actually a redox reaction.
So there is an exchange of electrons. Well, okay, so it's kind of like the oxidation stuff we're doing earlier. Let me show that to you here. So if we do the Na and the Cl on the left, okay, and then Na and Cl on the right, these are both 0. But on the left, this is +1 and this is -1, reactants and products.
And Cl2 is just -1 on the top, so that makes 2. And then with Cl times 2, we have 1. Wait, so which one's positive on the right? All right, so Na is
the Na is
positive.
positive, yeah. In the first column, if you go to your periodic table, anything in
Oh,
that
that's
first
plus.
column,
I got that mixed up. Okay.
yeah.
So this
And
is like an even, this is an even exchange of electrons, right?
yes, it looks like.
Even exchange of electrons. Therefore, it is a redox reaction. A true. Okay. And now the last one is number 28.
28, okay.
No, no. Let's see. 28 is supposed to be B, reduction half reaction. I don't know what that means.
So that we labeled this earlier. Reduction means that it, let me go back and find it. I mean, it was the other one. So the reduction loses electrons. Does that sound like what we did earlier, said earlier?
Yeah.
Okay. So that means you're going from negative to positive, or, positive to more positive, but see how it's going from 2 negative to 3 plus. That's what they're trying to get you to focus on,
Oh, so
that it loses electrons. And the half, I guess, is because there's other stuff going on here that they're not showing you.
which is B. So this looks like a lot of this is basically just practice, and understand the logic behind it.
Yeah, is there anything else you want us to cover before we just close out here? I'll make a few comments.
Yeah, because I have a calculus problem that's like the lady didn't teach us.
Okay,
Right.
yeah, we've got 20 minutes here if you want us to do some more stuff.
Yeah, let me just send this to you.
I mean, like you said, it's half of chemistry is math and the other half is what I'll call memorizing these things. Unless you're really into it, you're not gonna,
I can know it.
yeah, it's not gonna be like, because you're gonna get to things like, which has the bigger radius in the periodic table, and it's like, it's, these directions, and you're like, all right, well, all right,
I wouldn't
here.
even know that. Yeah.
Yeah, but the people that love this stuff, they really do. So, okay, number 2 here.
Mhm.
The position function for free falling objects S of t is -16 t squared plus v0 t plus s0. Rocket is launched from a 1 meter platform. So that means that s0 is 1. And the initial velocity v0 is 212 meters per second. So we've got our equation here, minus 16t squared plus 212t plus 1. That's part A. Is that okay?
Yeah.
All right. Part B is to find the average rate of change, the AROC, okay? And you're going from A equals 1 to B equals 3. So what you have to do is find S of 3 minus S of 1 over 3 minus 1. So your average rate of change is F of B minus F of A over B minus A. So we just find these in pieces. We say, okay, S of 3, put 3 in for T. S of 1, same thing. Put 1 in for T. Because we need those numbers. We need those numbers for this equation. I need to just step away for 10 seconds to turn something off on the stove. I'll be right back.
All right.
Okay, so you definitely need a calculator for this. Well, I guess you don't, but are you allowed to use a calculator on this?
Yeah.
Okay. All right, so the first one I got 493. Second one I got 197. So these are the numbers that go into that formula. 493 minus 197 over 3 minus 1. And that's 148 feet per second. Units are very important here.
Okay. Was the rocket speed at 2 seconds? Is this just putting 2 in for basically being f of 2 equals?
That the S is its position. So to find the speed, you need the velocity. Velocity is the derivative of the position function.
Okay.
So that would be minus 32t plus 212. That's the derivative of this line right here. This is a calculus class, you said, correct?
Yeah.
Okay.
I forgot about the, how do you take the derivative of that again? Is it f of x minus f of?
Power rule. Take the 2, bring it down, times minus 16.
She didn't teach us that yet.
Oh,
So
oh
I
really?
gotta,
Oh, that's okay.
yeah,
Never mind.
we're going slow.
Okay.
We're doing the f of x plus h minus f of a over.
Yeah. So okay. So to do this, you have to find the limit as h goes to 0. F of x plus h minus f of x all over h. So in this problem, it's really s of, and I guess it's t plus h will go. So that's minus 16 t plus h squared plus 212 t plus h plus 1. So we have to simplify this. So minus 16 t squared plus 2th plus h squared plus 212t 212h plus 1. Multiplying in here.
So yeah, it's so tedious. I don't know why we still do this.
Yeah, it's a lot. There's actually worse than this. There's these things called epsilon delta proofs that they don't teach anymore for the same reason. All right, so that's the thing that we needed for this. Limit h goes to 0. So we need all of this line that we just calculated right there. That's the s of t plus h minus s of t, which is the minus 16t squared plus 212t plus 1 all over H. And then limit H goes to 0. So it's all of this again, but we're going to change the signs of what's in parentheses. Okay, so all this stuff on the right here is going to become plus, and then this one becomes a minus, this next one, and then a minus 1. And then a bunch of stuff cancels. Thank goodness.
Yeah, it's trash, isn't it?
Yeah, so this goes with that one goes with that one, and then that goes with that one. So you're left over, everything you're left over with has an H in it, which is important here. Minus 32TH minus 16H squared plus 212H all over H. So you end up dividing everything by H.
So you get rid of this. So you're left with then you do negative 32t minus 16 times 0.
Yep.
Plus 212. And then
So
you're
that
left with,
that
oh
yeah,
my
that's really
God,
good. That's really good. That's your velocity function.
velocity function.
So
Well,
now
the
when it wants,
derivative of that, right? Or
what's
is
that?
it?
Say that again. Sorry.
So it's the derivative of that one,
Yes.
right?
Yes.
Okay.
Now, since you already know how to take the derivatives, you should know what your answer is before you get there. You just have to show the work to
So
get
I
there.
just put 2 in there and then
That's
you're
right.
done.
Yes.
Way too much work just to get to that.
Yeah.
Very ineffective, in my opinion.
Yeah.
212 minus 64, so it's 148.
Right.
148 meters per second. What is
Yeah.
that? Yeah,
Whatever the units are, I think it was feet per second because we're in
that's
the.
meters per second. It looks
Oh,
like.
it is okay.
When did the rocket hit the ground? So now we put 0 in here somewhere.
You're setting the original function equal to 0,
That's it. Oh,
and you can graph. You can. So I had the wrong units earlier. Meters per second. Thought this was the military. We're not metric. Okay, so yeah, you're setting minus 16t squared plus 212t plus 1 equal to 0. So
it's
this
a
one,
quadratic function or something.
yeah, and if you know the graph of this is it, boom, hits there. You would try factoring. I don't think this one factors.
Definitely
It
not.
does not. So you got to use quadratic formula if you're doing it by hand. A is minus 16, B is 212, C is 1. Are you allowed to use a graphing calculator?
Yeah, you can. Well, not the graphing calculator, but you can use a calculator.
Okay, so we can do this part. So it's minus B plus or minus the square root of B squared, 212 squared, minus 4 times minus 16 times 1 all over 2 times minus 16. And that's what's going to go on the calculator here.
Negative 212 plus or minus. Here's this huge number, 45,008 divided by negative 32. All right, let's see if there's like any chance of this being like a square rooted nicely. Nope, not even a little bit.
Yeah, it's not.
It does turn into slightly above 212, so it's like this weird number. So I'm just gonna round it to like 212.15. So I guess it'll be, if we subtract, we can't get the positive one. So we can do negative 212 minus 212.15 divided by negative 32. That way you get the positive stuff. So 212 minus this number and divided by negative 32, divided by negative 32, you get 0.0047.
The negative. So you have to actually subtract here to get the right answer in this one.
Because I get, so because I did what was it? 212
Negative
minus.
212. It's negative 212.
It's Newton. Oh, no, no wonder I got that wrong. Okay. So it's negative 212. Oh, I got that completely wrong. Okay. Divided by negative 32. Get 13.2 seconds. 30.3.
Yep. It's a healthy problem there. Lots to do.
Yeah, this is totally like useful and helpful in everyday life. I know that the physics part of it is definitely useful, but doing that much calculus to get to that is kind of dumb in my opinion.
Well, the guidance systems on missiles and rockets don't actually use this because this is an approximation to what really happens. So,
All right. I got a couple more problems that I could totally get through.
okay, sounds good.
And this one and I know these.
All right, yeah, thanks for sending that over here. All right, so I'm just uploading these, but we'll start with 3. Is that right?
Yeah.
The volume of a cone is given. There's the formula. It's got a height of 1 meter. And it says, how is the volume changing as a function of the radius when the radius is 3/4 of a meter? Okay.
1/4 of a meter.
So it's saying, how is the volume changing as a function of the radius? So it's saying it's asking for dV dr. dV dr. So by here you do have, I mean, you must be using derivative formulas for this. Yes, no, maybe.
I think so. Yeah, this is definitely
Okay. So
involved in derivative stuff.
So the rewrite of this is 1/3 pi h times r squared. Okay. And the reason you want to rewrite is you think of this 1/3 pi h as your constant. The derivative of r squared is 2r, and then the constant just comes with it.
Okay.
Okay, so now you're just evaluating at the given values. H is 1. The radius is 3/4.
I thought the radius said it's when the radius is 1/4 of a meter.
Is that what it says?
Yeah, this is 1/4 of a meter.
Oh, 1/4. Okay. Yeah, I'm zooming in and it just now uploaded. Okay. So that will change that to that one to 1/4. So your answer here is, let's see here, pi over 6. Now it's volume. So your volume is changing at a rate of meters cubed per meter.
Yeah.
So it ended up being meters squared. Probably won't use units on this.
Okay. So
Although they're giving you a lot of space. I mean, you might be having to use the whole definition of the derivative here. Like if you're asking me, I don't know. I really don't
yeah, it
know.
is. Yeah, we are doing the full definition of derivative. How would I be able to do that here?
Okay. Yeah, so it looks bad. So you need V of R plus. So the problem here is like we're used to using H, but you don't want to mix this right here, that
Make it
H.
like an X or something.
Yeah, we can do R plus X would be fine. Minus V of X. I'm sorry, V of R. V of R. And then the limit as X goes to 0. So yeah, you do have to go and so you would do your V of R plus X is 1/3 pi H R plus X squared.
Mhm.
So it's 1/3 pi H R squared plus 2XH plus X squared. And so that comes down here, limit as x goes to 0. I'm gonna distribute in because we're gonna actually, yeah, I guess that'll make it easier for you. 1/3 pi h r squared plus 2/3 pi. I'm sorry, I've got this backwards. This is xr x
Yeah, I was getting
rx
confused. I was like, what we do with the,
rx
I thought we
rx
put the H as X.
pi h rx.
How come we have, how come we put X for H again?
Because h is represented by as the height in this, and you don't want to mix up the h and
Oh,
the
yeah.
is the difference between the two slopes, secant slopes, horizontal distance. 1/3 pi h x squared minus 1/3 pi r squared h all over h, no, x. Oh boy. Okay. All right, this is kind of a mess. Limit x goes to 0 so that these two cancel. And you're left with 2/3 pi hrx plus 1/3 pi hx squared all over x. And then you cancel pi hr plus 1/3 pi hx. Like that.
That's a lot of stuff.
Yeah, and then you still got to put in the numbers like we did earlier. So 2/3 pi times 1 times 1/4. So it still ends up being pi over 6 meters squared.
Yeah. For whatever reason in my class, you want us to put meters cubed over meters. It's like a weird
Okay, do what they want.
finicky thing. All right, I set you number 5. Could we just
Okay.
look for this really quick? I don't know the derivative with a graph. I'm not sure how you do it.
Yeah, not too bad here. We're gonna do it. You're gonna get a fast
Here, f of
answer.
2 is just 2. You get rid of that off the bat.
Yep. So you got that one there. Great. So f prime of 3 means what is the slope of the tangent line at 3? And do you see that it's a horizontal tangent there?
Yeah, this one's 0.
That's 0. At -2. So maybe, I mean, I don't know. We maybe go to this. So at -2, it's like you draw the tangent line
Mhm.
and you're just calculating slope. So
Yeah, so you
like
take a
to me, this
couple
is
of
like
points.
I'm looking at I'm looking at 4 up, 2 right. So I might go like 4 over 2 on that one.
Mhm.
-1, you know, draw a tangent line, draw kind of until you hit some nice points. Draw the triangle. So it's up 2 and right 2. So that's 2 over 2, which is 1. All right, now the limit, C and D here, the limit as x approaches 3, basically they're looking for the y value. What is the y value in both of these situations? C, it's 1. At -2, the y value is 3. So key
So,
is y value.
so what goes to -2, you look for the y value, is that what you're saying?
Yes, the limit, think of the limit as the y value for now.
Okay. Equals, all right, so equals 3, then this one. Okay. Oh. Actually, can I send you the graph, the derivative of this one? This one, I just need to know how to do this. You can skip the other 2 problems. I just don't know how to graph a derivative of a function.
All right, let's let that load up here. All Alright, so step one is to notice where the peaks and valleys are. So there's a peak right there. So that's gonna be an x-intercept. There's a min there. It's gonna be an intercept. And then there's one here right at the middle, which is that. So then what you have to look at, and I'm gonna do this in blue here. This blue is positive slope. Do you agree with that?
Yeah, it's a positive slope.
So that transforms into that there. The green here is negative slope.
Negative slope.
This green is also negative slope.
Negative slope. Okay.
And then this other over here, which I'm running out of colors,
Positive
No.
slope.
this one's
Yeah.
positive slope. So that's it.
Yeah, colors don't really matter in this case of 1, x 0, 0, and then this weird thing. So it's
All right.
like
So I do have
that-
stuff